Yes, you're welcome once again to this episode. Thank you for watching. Thank you for subscribing. Akid Gloria, this is dedicated to you and all of you are watching. So today we want to look at solving quadratic equations, and we are going to use what we know already, a method of factorization. Alright, we know to solve an equation, it means finding the value of the unknown in that equation. So it's the same thing we are going to do here, but we need to remind ourselves about factorization because we are going to use factorization. You can watch the lessons about the quadratic expressions and factorization if you didn't watch them, and they will guide you about everything. So if you have two numbers, for example x and y, and if xy equals to 0, then what do we get from this expression here? It means for x times y to be equal to 0, either x is equal to 0, such that if x is 0, then we have 0 times y giving us a 0, or we have y should be 0, okay, for this to be equal to 0, so that y is 0 times x is equal to a 0, or both of them should be 0, okay, so that 0 times 0 is a 0. So we are looking at the condition when x, y is equal to 0. So it is either x as 0, so that when we have x as 0, all of this goes to 0, or y is a 0, or both of them are what? As zeros. Alright, so what does it mean if we have an expression like x minus 1 into x plus 3 equals to 0? The same thing, we are going to use this idea. If these are two factors, we have x minus 1 and x plus 3 are factors of this or expression, then either for that expression to be equal to 0, this to be equal to 0, either x minus 1 is a 0, or x plus a 3 is a 0. And you realize that if we solve these equations, like we have x minus 1 equals to 0, if we take 1 the other side, then to give us x as a 1. And then if we consider this, we take 3 the other side, we shall have x as negative 3. So this is the I that we are going to use to solve quadratic equations using the method of factorization. First, factorize to have something like this. And when you have something like this, then we use this idea that we've developed here. Alright, let's look at some examples. Though we need to note still that since we are working with quadratic equation, they have two solutions. Like we have two values of x. If it is in y, then we have two values of y. So every quadratic equation has two solutions. So examples. Okay, A, we want to solve for x. We are solving for x in everything here. So we have x plus 4 into x plus 2. These are already factors, okay? So here we'll just say for all this to be equal to 0, then either x plus 4 equals to 0, or x plus 2 equals to 0. Okay, so if we have x plus 4 as a 0, then this one represents, shows us that x, when you take 4 the other side, x will be equal to negative 4. Then if x plus 2 is equal to 0, then our x will be negative 2. So meaning the values of x here are negative 4 and negative 2. Good. Example B, if you have x into x plus 5 equals to 0. The same thing, we have already the factors here. We have x and then x plus 5. So either, for this, all of this to be equal to 0, either x is 0, okay, or x plus 5 is equal to 0. So this one has already given us one value of x as a 0. Now this one should give us the second value of x, because remember we said the quadratic equations will always have two solutions. So if x plus 5 is 0, then it means our x is equal to negative 5. When we take 5 to the right hand side, yeah, that's what we mean by that. Okay, let's look at more examples. Number C, or part C. If you have x squared plus x minus 2 equals to 0. Now here we have to find our factors. Okay, here we've been given the factors. Now this is where we go to factorization. We said find two numbers so that the sum is equal to the coefficient of x, which is 1, and then the product should be equal to this constant here, which is negative 2. Okay, this constant term. So which two numbers give us, or we actually look for the factors of negative 2 that add up to 1. So my factors, my factors of negative 2 will be negative 1 and a 2. You see, when we add negative 1 plus 2, we get a 1. When we multiply, we get negative 2, which is this. So we expand. So when we expand, we have x squared. So the x is substituted by these two terms. So like negative 1x plus 2x minus 2. Remember, we said we substitute this because this negative 1x plus 2x takes us back to this. So there is no difference in the two statements. So we group this and this, then this and this, factor out the common factor. Here is x. What do I remain with here? X minus 1 plus, what do I take out here? A 2 is common. We have a 2 here, we have a 2 here. What is remaining? We have x here, we have a 1 remaining here, and it is still equal to 0. Since x minus 1 is common on both terms, we take it out. When we take it out, we remain with x here and a 2 here plus a 2 equals to 0. So we have factors now here. So we said that this is equal to 0 if either x minus 2 is 0 or x plus 2 is 0. Okay, to multiply two numbers and it gives a 0, the product gives a 0, it means one of those numbers should be 0 or all those numbers should be 0. So either x minus 1 is equal to 0, giving us our x as 1, or x plus a 2 equals to 0, giving us our x as negative 2. Yes, let's look at part D. Part D, x to the power 2 minus 5x plus 4 equals to 0. Look for factors of 4 that give you a sum of negative 5. Which factors are those? We have negative 4 and negative 1. When we add up negative 4 minus 1, when we add up negative 4 and negative 1, we get a negative 5. When we multiply, we get a 4. So we expand, so this will be x squared minus 4x minus x plus a 4 equals to 0. When we factor out, I can group this and this, this and this. What is common here? X is common. When I take it out, I remain with x here minus a 4. Then what is common here? Since I want these brackets, the bracket to be the same, I already have this 4 here. I have x here, but this 4 has to be negative because I have a negative here, and this should be a positive. So it means when I take out a negative 1, Okay, it means this will remain x, and this one will change to a minus 4. So that you see the brackets are the same. If they are the same, we take out the common bracket, which is x minus 4, into what remains here. It is x. What remains here is 1, negative 1, equals to 0. So we said for this to be equal to 0, either x minus 4 is equal to 0, giving us x as, when we take a 4 this side, it gives us x as a 4, or x minus 1 is equal to 0, and when we take a 1 this side, it gives us x as a 1. Yes, we are good to go. So quadratic equations have two solutions. Don't forget, looking at part E, if you have x squared plus 5x plus 6 equals to 0, look for two factors of 6 that give you a sum of 5. Which factors are those? We have a 2 and a 3. When we add up 2 and 3, we get a 5. When we multiply 2 and 3, we get a 6. So we expand. This is x squared plus 2x plus 3x plus 6 equals to 0. We can group. Okay, when you factor out here, x is common here and here. What remains here, it is x plus a 2. What is common here is a 3. When I take it out, I remain with x plus a 2 equals to 0. So eventually see that these brackets are the same. So we factor out one bracket, x plus a 2. What remains here will remain with x. What would remain with here is a 3, giving here 0. So either x plus 2 equals to 0, giving us x as a negative 2, or x plus 3 equals to 0, giving us x as a negative 3. Okay, let's look at more examples so that we get this very well. Yeah. Example F. By the time we finish all these examples, this should not be a disturbing topic anymore. Equals to 1. So what we do here, we need a 0 on the right hand side. Okay, so take a 1 to the left hand side, which will be x squared minus x minus 29 minus 1 equals to 0. When we simplify, it will be x squared minus x minus 30 equals to 0. Look for two factors of negative 30 that give you a sum of negative 1. So we have, I think, a negative 6 and a 5. Because when we add up negative 6 and a 5, we get negative 1 here. And when we multiply, we get negative 30. Expand, we have x squared minus 6x plus 5x minus 30 equals to 0. Group and factor out the common factors. Here I have x, and here also there's x. So when I factor out x, I remain with x here. Here I remain with a 6, negative 6 here. Then here what is common, I think it's a 5. When you take it out, remain with x here, and here remain with a negative 6 as well. So the brackets are the same. Factor out one bracket, and then what remains here, remain with x plus a 5. Either x minus 6 equals to 0, giving us x as 6. When 6 crosses the equal sign, changes this, or x plus 5 equals to 0, giving us x as negative 5. Yes, I hope we are good to go. Yes. Let's look at more examples. D. If you have x squared minus 16 equals to 0. A bit tricky, but very easy. This one, without even, you can clearly see that I can write this as 4 squared. Okay, so you can see that this is a difference of 2 squares, if you remember. Then I can write this in terms of factors, like x minus 4 into x plus a 4 equal to 0. So we have already the factors now. So either x minus 4 is 0, giving us x as a 4, or x plus a 4 equals to 0, giving us x as a negative 4. Good, you see, that was quite easy, maybe. Let's look at h. If you have x squared minus 16x plus 64 equals to 0. What are the factors here? What are the factors here? What are the factors here? So that when we multiply them, we get 64, and then when we add, we get negative 16. The factors are negative 8, negative 8. So when we expand, this is x squared minus 8x minus 8x plus 64 equals to 0. Group, and you factor out the common factor. So when you factor out, we have, let me first write it, we have x squared minus 8x minus 8x plus 64 equals to 0. After grouping, what is common here? It is x, take it out, remain with x minus 8. Okay, what is common here? Since we want a negative here, we can take out a negative, because this x should remain positive. So when I remove the negative and the 8, because it is common, I remain with x inside here plus 8. So this will be minus. This will be minus, equals to 0. So you see we have 8 minus, x minus 8. This is also x minus 8. So we take out x minus 8, and what do we remain with here? It is x. What about here? It is negative 8 equals to 0. So either x minus 8 equals to 0, or x minus 8 is equal to 0. So it's like we have repeated roots here. Our x is 8. Like they are repeated roots. This is a perfect square. It was a perfect square, that's why it is giving us a perfect square root. Okay, so like that's why we're having two repeated values, 8, because even when we say x minus 8 equals to 0, we end up with x as 8. So meaning the values of x are 2, 8, 8. They're repeated roots. There's no problem with that. Okay, so we want to look at some special question or item here. If you have 6x squared plus 5x minus 4 equals to 0. What is interesting here, the coefficient of x squared is not 1, like with the previous numbers, the previous questions. So what do we do in such a case? If the coefficient of x squared is not a 1, then get that coefficient of x squared, multiply it with this constant term. So meaning we have 6 times negative 4 giving us a negative 24. Okay. Now, when we are getting the sum and the product, or the two factors, get the factors of negative 24, not the factors of negative 4. Now, we use this new number after multiplying the constant term with the coefficient of x squared. So look for two numbers that give us a sum of 5 and a product of negative 24. Okay, so which numbers are those? Those numbers are a negative 3 and 8. When we add negative 3 plus 8, we get 5. When we multiply negative 3 times 8, we get negative 24. So that's what we wanted. So note this, when the coefficient of x squared is not 1, get that coefficient. First of all, multiply it with this constant term. Then the product should give us that new value you've gotten there. In this case, it is negative 24. The product should be negative 24. Then the sum remains this coefficient of x. So we expand as usual, but we don't bring the 24 here. When we are expanding, you keep the 4 plus 8x minus a 4 equals to 0. Factorize out what is common here. Group and factorize out what is common here. I have a 3x. When I take out a 3x, here I remain with a 2x. Yeah. Then here what do I remain with? I remain with minus 1. Then here, if you take out a 2, you remain with a 4. Take out a 4. It's a 4 that is common. So here we shall remain with a 2x minus a 1 equals to 0. So eventually the brackets are the same. Take out one bracket. And what remains here will remain with 3x plus a 4 equal to 0. So either 2x minus 1 is equal to 0, which gives us 2x as a 1 when we take 1 this side. So we divide through by 2 on both sides, we shall have x as a half, or 3x plus a 4 equals to 0. When we take 4 the other side, we remain with 3x equals negative 4. Divide through by 3 on both sides. So our x is negative 4 over 3. Yes, that is it. Let's look at another example to make this clear. J, we can ask you to factorize 3x squared minus 2x plus 7. Hence, solve 3x squared minus 2x plus 7 equals to 0. So there's nothing different here. We do the same thing we've been doing. So we start by factorizing. We have 3x squared minus 2x plus 7. Find factors of what? Like the sum of those numbers should be negative 2. And the product, we said, when the coefficient of x squared is not 1, like in this case, get this coefficient, multiply it with a constant term, which is 7, and that should be the product, which is 21. So which two numbers? Sorry, this was a 22. We have a 22 here. So which two numbers do we add up to get negative 22? But when we multiply them, we get 21. That is a negative 21 and a negative 1. When we expand, we shall have 3x squared minus 21x minus x plus 7. Factorize out after grouping. What is common here? It's a 3x. What is common? What is remaining here? It is x. What about here? We remain with negative 7. Then here, since we want x to be positive, meaning we take out a negative 1 so that this one remains x, and then this minus 1 will affect, means we've taken out a minus, remain with the minus inside. So when we see these brackets are the same, factor out 1. So what do we remain with here? Remain with 3x, and here minus 1. So this is the factorized statement. Now we go on hence solve. So if they say hence, start from where you stopped. Hence solve. So to solve, we have this already, minus 2x plus 7 equaling to x minus 7 into 3x minus 1. But they want us to solve this equal to 0, meaning if this is equal to 0, also this one is equal to 0. So meaning we have x minus 7 into x minus 1 equal to 0. So either we just start from there, we've already factorized. Either x minus 7 is equal to 0, giving us x as a 7, or this is 3, or 3x minus 1 is equal to 0, giving us 3x as a 1 and x as 1 over 3. Yes, we are good to go. One more example, and the last one. One more example. We have 6x squared minus x minus 1 equals to 0. Alright, the same thing, find two numbers. When you add them, the sum should be equal to negative 1. The product, guess what it is? Is it negative 1? Negative 6. Should be negative 6. We said multiply the coefficient of x squared with this constant term in case the coefficient of x squared is not 1. So meaning the product should be negative 6 and the sum negative 1. So which numbers are those? We have a 2, negative 3. Expand. So we have 6x squared minus 2x. This is a plus, sorry, because this is a 2. It's a positive. Then minus 3x minus a 1 equals to 0. Yeah, we say don't bring this product here. You keep the 1. Factor out the common factors here. What is common here? We have 2x. What remains here? We remain with 3x. What about here? Plus 1. Here what is common? It's a minus 1. When we take it out, remain with 3x plus 1 equals to 0. So since the brackets are the same, factor out the brackets. What do we remain with here? We remain with 2x, and here we remain with minus 1 equals to 0. Alright, so either I explained why we use this before. Either 3x plus 1 is equal to 0, giving us 3x as negative 1, so x is equal to negative 1 over 3. Or 2x minus 1 is equal to 0, giving us 2x as a 1, and when we divide both sides by 2, we remain with x as a half. Thank you for watching. Don't forget to subscribe if this has been useful to you. Don't forget to share, to like, and comment. In case of any questions that you need assistance, forward them in the comment section or on the WhatsApp number. See you.